Thank you. Thanks. It's a great pleasure to be here. I apologize. I had a scheduling conflict and was a little late getting here, but not too bad. NuScale power training. This is I really tuned into what I heard before. There's a lot of the same stuff we're working on, same types of things, especially for in the field operations for the NuScale plant design. I got to tell you, a lot of our material that we developed was sponsored and paid for by the Department of Energy, so we have to give them credit in a lot of our presentations. So that's what this slide is here. So NuScale has a small modular reactor. It's very transformational. There's a lot of things different about it than what conventional nuclear power is. And there's a lot of things that are quite the same too. It's scalable, reliable, carbon-free power, and we can meet our global decarbonization targets with that. I think there's quite a few studies you've seen where right now, if we had to quickly get to zero carbon, nuclear is being proposed as part of that solution to get us there. So one of the big challenges we had in designing a NuScale station was our flagship plant. Our flagship station has 12 reactor modules. Most conventional nuclear plants might have up to 2 control rooms that are and 2 specific reactors, 2 larger reactors that are controlled. We have up to 12. So the challenge was typically there's 3 to 4 licensed control room operators needed to be at the controls of the control room for each reactor. How are you going to do this for 12? How big is the room going to have to be? How, are you going to have 4 operators for the 12 reactor plants? And one of the things we did right out of the bat, I think NuScale was good at, is they hired a bunch of current and former operators, which I was one. I was licensed at DC Cook in Michigan. It's a 2-unit large PWR. I was there for 26 years, either in training or operations training. So that was a challenge. The NRC has to, the Nuclear Regulatory Commission has to accept our plan for what we're going to do as far as how we're going to man the control room and how we're going to operate. So we started off very early with trying to design the control systems for the plant that required very few operator intense attention. So you'll see a lot more automations where in the previous plant that I was at, it was you go find this valve, open this valve, and find another valve in the control, open it up, and you're checking off through your paper procedure, and you go somewhere else maybe to start the pump, and you have to send somebody out locally because you don't have the flow meter in the control room, so they got to make sure the flow is good. It was very manpower intensive for a lot of the evolutions, where we started off from the beginning with our control processes. So if you wanted to do a evolution, that evolution was automated inside the module control system. Then the operator became more of the peer checker in making sure that automation was functioning correctly. And we designed the system so that you could monitor some key indicators to make sure that if I needed to stop automation, the operator could recognize and do that right away. So very advanced alarm recognition. There's alarm filtering for that. And as far as processes, we got it. Initially, we had it down to, I think, 5. When we did some of our testing, 5 control room operators for 12 units, and then we later did another test using the same success criteria after we changed some of the way the control in the control room and automations operated, and we're at 3 licensed control room operators now. So that was a very big accomplishment, and at first when I went in there, it seemed like it was incredibly busy, but instead of having some of the transformations I've seen going to digital, is in the control room you used to have an analog gauge that said, this hydraulic pressure, and it had a meter on it, was gauged, and they actually fed the hydraulic pressure right up to the control room. And when we transferred over to digital, the operator's like, I want this big TV screen to show a picture of this big gauge so I can see the needle move. And because it was just lack of the comfort of how you're going to adapt to digital. And this was a huge transition to me. We were, at the plant I left, we were slowly changing systems over. We probably had 5 or 6 systems that major systems were converted to digital. And we became comfortable with using them and losing a lot of the things that we were familiar with as far as I could, look across the room, 40 feet away and see what this gauge reads. You may not necessarily always need that. So there's a lot of changes there. Our emergency operating procedures. So if we get into a situation where the plant is in emergency operating procedures, the computer actually, for the module protection system, analyzes what the emergency is and gives you the instant criteria to say you're an emergency operating procedure. It takes you to there in the electronic procedures and you can step through it. And compared to a conventional plant, it's extremely simple. We had at the plant, we had a whole rack of paper procedures just for emergency operating procedures. This is all on one screen, and there's not a procedure now in the NuScale plant for EOP that would take you more than 15 minutes to complete, to be successful. Part of that is because of the design. The design is a passively cooled, there's no actions that an operator has to take to keep the plant safe under any condition, under any accident. The plant simply shuts down, isolates its module, and it rejects its heat to a pool, and it sits there. So there's nothing the operator could do or could not do that would jeopardize that safety function. So that's makes a lot of our task a lot simpler from designing from an operation perspective. The last bullet there, we had an integrated system validation test, which is kind of what we talked about. We brought in people from all different scopes, kind of a product test our simulator and our concept of how we would human factor design this control room. We had people that were from previous nuclear plants. They had anywhere from 10 to 12 years experience in the control room. We asked them, we had three of those, they were our supervisors. So they kind of knew the whole nuclear power world from that aspect. We brought them in for about 6 months. Along with, we brought people, some college graduates right out of college, engineering graduates, students that had no real nuclear experience at all. And we brought in people that were high school graduates, and they were our control room operators. So we decided to take a very low mix. We put together a training program that took about 6 months to train everybody on the systems that we had. And then we ran them through the simulator with all the casualties, all the normal things that you'd see for plant, and then we recorded that and validated it, made changes to the design of the control room and HFE until we were comfortable that we could do that with 3 people. So a typical legacy, or the typical plants that are operating today, plant I came from, if you were going to become a control room licensed operator, you would need anywhere from 16 to 24 months in the field as a field operator, then about 18 months of off-shift training to get a license, and then once you have a license, every 5 weeks you have 40 hours of a training week that you attend to maintain proficiency in the tasks that you need to do. So our goal was to determine if that was appropriate for one. Is this appropriate for a NuScale plant as simplistic as it is? If there aren't any safety-related tasks or reactor safety tasks that the operator needs to do to protect the health of the public, do we need to have as robust of a program for training as a typical nuclear power plant does? So again, we are dispatching a lot of our simulator technology in universities. So we can take a simulator and it's all digital. We can bring it in. It has all the modeling of the reactor, a secondary plant, all the processes, and we show the universities how to run the simulator, and then in their nuclear technology programs, they have that asset to use, and we get a lot of feedback from it too, especially from a human factors standpoint, because you're showing it to people that have not been, in the fleet of nuclear for any time at all. So I think we have 3 simulators now in the universities. We're installing one in Idaho, University of Idaho next week. and I think that'll be number 4. There's also requests to install these same simulators in Europe and a lot of Eastern world countries, so working towards that. We are also putting together a package that for whoever would buy a NuScale plant, if it made economical sense for them to contract NuScale to provide the training services in a centralized location. And this is where a lot of the virtual reality and a lot of the things that we wouldn't have to be at the plant, or a student wouldn't have to be at the plant, we could do as a service. So we're working towards that. It's still up in the air whether or not it makes economic sense or not. Maybe a operating company wants to have their own training program. We're certainly willing to work with that. Our big vision is we want to make sure we can bring to market the best of the newest SMR technology available, and kind of clear away if there's maintenance issues or things like that. We try to clear that up as our engineering and technology company. Let's see, what else we got here? We would have simulator services, services for commissioning. We have a group right now that's working at the processes and procedures for startup and testing of the first plant that we're building at Idaho National Labs on their property there. It'll be a six module plant that's scheduled to come online and make electricity in 2029 right now. So we're submitting our final design of the buildings and the station to the NRC for approval at the end of this year, and that should take about 1.5 years or 2 to get finally approved. We'll have construction activities that are starting up in the meantime, expecting that we will be successful. Another feature that we would have is because of our proposed emergency planning zone areas, so we don't have to have a 5 or a 20-mile emergency planning zone areas where you have to show that you can provide evacuation if you had some sort of a release or an accident where you want to evacuate people. The reactors and the modules are small enough that our dose rates aren't infected anywhere outside of the 35-acre design of the plant, so we don't need any external emergency planning zones. So if you had a power plant that was kind of in a tight, heavily populated area that was maybe a fossil fuel or something that you wanted to replace it with a NuScale plant, you don't have a lot of issues with working with the state to try to figure out how you're going to put a nuclear plant in this highly populated zone and still be able to safely evacuate or shelter people if that becomes necessary. All that has to be figured out ahead of time before you're decided to put a plant there. So again, we can put right on the existing coal site. It actually saves a lot of money as far as you most likely already have a switch yard there. You have access to water. You have a rail system. You have a lot of infrastructure that's already there. In our training that we're developing, if we were to, say, go in and replace a coal plant, one of the concerns was you're going to let all the people that worked at the coal plant go, and they're going to have to find other jobs because a nuclear plant job is so hard, compared to maybe some of the other technologies. So our training programs are focused around being able to parallel transfer over those current workers in there and bring them right into the NuScale design. So it's not to make it any more complex than it has to be. It's a chart showing some of the direct parallel conversions that we would have in a coal plant that would transfer over to NuScale. We'd be able to take a lot of the tasks that they're already proficient at. Say they know how to do a valve lineup in the plant, or they know how to safely install, how to safely work on a piece of equipment. Those tasks would be directly transferable over into our training program, and we could minimize the gap training that we'd have to do between fossil fuels and nuclear. So we're out to change the power that changes the world, and that's all I have. Thanks.